So these are crazy limits. Check out this top one right here. If we were to plug in infinity to each of these terms right here, because that's what we can do. The basic laws of limits say that you could, if you wanted to, just, oops, I've switched the page. You could, if you wanted to, just find the limit of that, 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 add them, subtract them, then divide them, and then you could get the answer. But if you look at each of these individually, if I find the limit of this one, that's going to approach infinity.
Yeah.
Because I have x raised to the 7 over 2, and you know what we were just talking about in the other video, that's just going to be infinity. Right here, that's x raised to negative 1/2. What's that going to approach?
0.
That's going to approach 0 because that's a negative exponent. So if it's a negative exponent, it's going to throw it down on the denominator of a fraction, and so it's going to approach 0. So we have infinity minus 0. This guy right here is going to approach infinity. This guy right here is going to approach infinity also. Right, the top one's supposed to be plus. Okay, but it doesn't really matter, right? Because we still have infinity over, I guess if you subtract 2 infinities, wouldn't that technically be 0?
No.
Yes.
It doesn't matter. Is this indeterminate? Yeah, this is an indeterminate, and so is this. They're both indeterminate forms. And so we have to change this guy. We got to manipulate him a little bit to see what this limit actually is, or how does it exist. So what we're going to do is we're going to take the top, yeah.
All positive exponents approach infinity.
Okay, we're going to take the numerator and we're going to take the denominator and we're going to divide both of them by the highest degree on the bottom, by the term with the highest degree on the bottom. So on the bottom we have x to the second power. That's our highest one. So we're going to divide both the top and the bottom by x to the negative 2. What I'm going to do is I'm going to multiply the top by x to the negative 2 and x to the negative 2. And some of you guys might go, wait, I thought you said you were going to divide it by x squared. Well, I technically am. If I multiply something, we'll just say a. I'm going to multiply a times x to the negative 2. Well, x to the negative 2 is the same as 1 over x squared, right? And if I multiply this times the a, then I'm going to get a divided by x squared. So a divided by x squared. So I would get that. So I mean I like thinking about multiplication more than I'd like to think about division. Let's multiply everything by the x to the negative 2 power. Now what do you do with the exponents when you multiply them together? Add them. Okay, so we have 3 x to the, and I'm going to have to go negative 2 plus 7 over 2. Okay, so I'm going to make a common denominator here, so now it's negative 4. So we have negative 4 plus 7, which is 3 over 2, so we have 3 over 2. Double check my math right there, because I'm prone to mistakes. And then the next one's going to be plus 7, x to the, now I have a negative 1/2 plus a negative 2. So I have negative 2, and I'm going to add a negative 1/2. Again, that's a 4 on the bottom, that'll be negative 4 up top, so I'm going to have negative 5. Oh wait, yeah, why is it 4? See, there am I going, making mistakes again. So I'll put a 2 right there. Yeah, then that would be negative 4. Okay. I have negative 5 over 2, so it'll be negative 5 over 2. And then for the denominator, cool stuff happens. If I multiply x to the negative 2 times x to the 2, that would be negative 2 and 2, which would be x to the 0, right? So that's just going to be 1. Then I have minus, and I have this nasty guy right here. I have x to the 1/2. Now, if I had a positive 1/2 here, let's see how that would change it. Let's see. It'd be negative 4 over 2, and I add a 1/2 to it. That would be a negative 3 over 2. Okay. So we have a negative 3 over 2, x to the negative 3 over 2. Yeah, he's pretty nasty. Okay, so now let's find the limit of each of these. If I find the limit of this one, that's going to be infinity, right? Because it has a positive exponent. It doesn't matter if it's a whole number or a fraction. That's going to be infinity. Then I have to add this one. What's this one going to be? I have a negative exponent. What's that going to be? I'm going to add 0. And on the bottom, I have a 1. The limit as x approaches infinity of 1 is just 1. And this one right here, what's that going to be? It has a negative exponent. So I'm going to go subtract. It's going to be 0. So now I have infinity divided by 1, which is not indeterminate.
Infinity.
So this is just infinity. The reason why we decided to divide by the term that had the highest power is because that would make every other term have a negative exponent. And when you have negative exponents, you know that's just going to approach 0, right? So that's why, like, if this, let's say this was x to the 1 right here, I would want to choose this one because it would make that one negative. If I chose 1/2, this one wouldn't be negative, and it's going to approach infinity. I'm going to get an indeterminate form. Okay, so let's look at this this next one right here. Now this one is a little nasty. Okay, if you can recall, you guys remember x to the third? Like if you had a square root of that, you guys know what this is with exponent? X to the what?
1/3.
It's 3 is on top because he's the power, and 2 goes on the bottom because he's the root. The power goes on top, the root goes on the bottom. Some people have said flower power, and they grow the roots down there. I don't know.
That's
Okay.
cool. I want to learn that.
Yeah, it kind of helps. Okay, so we can use this to change this right here. We're going to divide that and divide that by this guy. Okay? Now, I got to warn you guys because this is the fear I have that some of you guys will do. Some of you guys will do this. And if you thought this, that's pretty cool that you thought this, but it doesn't work. Some of you guys will change this to the 1/2 power. You'll change this to say x or x to the third plus 1 to the 1/2 power, and then you'll say this. X to the that would be 3/2, and then you would say plus 1 to the 1/2 power. Now you can't do this. This is not true. They do not equal each other. Okay, and the reason why this is not true. All right, make sure you do not do that. Okay, if you have a power, think about x to the third plus 1. If I was raising this to the second power, that would mean x to the third plus 1 times x to the third plus 1. Okay, you cannot distribute the power like that. That's against rules. All right, so I'm going to multiply the top and the bottom by x to the 3/2.
Hey, why? Oh, wait, just kidding.
Okay, now the top one's not that bad. I can. Oh wait, I'm sorry. They're supposed to be negative because we're technically dividing. All right, just like before. So we gotta multiply the top by x to the negative 3/2 and the bottom by x to the negative 3/2. So the top's not that bad. Let's write the top out. The top's gonna be x to the, that's 2 plus negative 3/2. Let's write that out. 2 plus negative 3/2. This would be a 2. That would be a 4. So this would equal 1/2. So it's gonna be x to the 1/2 on top. But what are we gonna get on the bottom? That's kind of weird. Multiplying this times this. All right. You guys ready for this? You got to hang with me here. Okay, this is how we're going to do it. Now, like I said before, we cannot split this one up right here. But we know that if you have a and b multiplying to each other with the square root, it's the same as going square root of a times the square root of b. You guys remember that? So what I'm going to do here is I'm going to take this x to the third plus 1, and I'm going to factor out x to the third. So if I factor out x to the third, it's going to be x to the third. I'd be dividing, so divide that by x to the third, and I divide this one by x to the third. This would be 1. And what is 1 divided by x to the third?
1.
Yeah, you can say 1 over x to the third, or you can say x to the negative third. These are both being square rooted. So now I can split this one up, right? I can split this one up because we have a term right here and a term right here multiplying to each other. So I can technically say this. X to the third, square root of that, times 1 plus 1 over, actually I'm going to say x to the negative 3. Okay? So now I can split it up. Now, if I have this, that's this, right? Okay, if that's that, check that out. I can rewrite that over here. Let's clean it up. We can have it'd be 1 plus x to the negative third, and in front we have x to the 3/2, and we're multiplying this. Remember, we're multiplying this times x to the negative 3/2. You guys with me? Okay, I did a lot of stuff right here. We agreed that we're going to multiply the top and the bottom by this, and we look at the bottom, we went all junk, and then I showed you guys right here how we can split it up using algebra. Now I have x to the 3/2 times x to the negative 3/2. If I multiply those two together, I add those exponents,
You get 1.
and I get 0. So it's going to be x to the 0, right?
1.
Which would be 1. And so the denominator is just going to be the square root of 1 plus x to the negative 3. And on top we have x to the 1/2. Why is that negative?
Oh.
That's negative because remember it was on the denominator.
Multiply the
Okay.
negative 2/2.
So now, yeah, you can leave it like that. You don't have to use the x to the negative 3. Okay, so now if I plug in infinity to this, it's going to approach. What's that going to approach?
Negative, no.
Did I do something wrong?
Multiply the negative 3/2 to the square root.
No, I did. The x.
No, to the bottom you didn't multiply it to the 1 plus.
I only have to multiply it to one of these. I can multiply it to this term or this term, and I chose to multiply this to this. It's not plus right here. If it was plus, I'd have to distribute.
Okay.
But there's no plus right there. Because they're multiplying, you just have to multiply to this one or this one. I chose this one because that would equal 1. All right? So now, good question. Thank you. As x approaches infinity right here,
0.
that approaches
Infinity.
infinity. As x approaches infinity in this one, what does that equal?
0, 0.
That's 0. So we have 1 plus 0 in there. And what is the square root of 1?
1.
So we just have this.
Hey.
That's a lot of work just to say.
Yeah, it is a lot of work. These are hard ones.
Can you just guess?